Okay, let's continue with lesson 2. First, we're going to start with observation versus inference. Observation is the information gathered through our 5 senses. Inference is an explanation or interpretation of what you're observing using prior knowledge. You use your observations to make inferences, and then your inferences to make what is called models. So what is a model? Perhaps you think of these. All of the previous models are what we would call a simplified version of reality. They're used to understand or explain something that we have trouble putting into words. And then they also suggest how things work or how they might work. There are 3 major types of models. There's a conceptual model, which an example of that would be the carbon cycle. The second one is the mathematical model, and you know of E equals mc squared, Einstein's theory of relativity. And then a physical would be a globe, where we make the Earth look small and we can hold it in our own hands. A good model should be able to do at least 3 things. 1, explain the data at hand. 2, accurately predict the results of future experiments. And 3, be consistent with prior knowledge. It means we build upon what is known and continue to be logically consistent. We also, in talking about models, must consider that there are some problems and limitations with these models. First of all, there is going to be some confusion sometimes between model and reality. That's very common among students, especially the younger you go with students. That's because models are often made very small or very large to help us understand, and we must understand that they are not what is real. They are a conceptualization of what is real. And secondly, they could limit our mental conceptualization of the natural world if we're not careful. This brings us to scientific argumentation. Scientists do make arguments to help explain what they believe to be true, and they have to have some kind of support for why they make those claims. So first of all, why do scientists make arguments? Scientists make arguments to convince others what they believe is true. For example, you've heard of global warming. There are some sides that believe in global warming, and there are other sides that do not. A good scientist is going to make an argument for why or why not he believes global warming to be true. There are 3 parts to a scientific argument. First, a claim, then evidence, and then reason. First, the claim. The claim is a statement that is based on something that you believe to be true. Let me take you through an example of how this works. For example, should Mr. Hall be considered a good guitarist? For the record, he's not. But let's just, for the sake of argument, argue one way or the other. And first of all, the claim is yes, Mr. Hall should be considered a good guitarist. The evidence portion is where we have data that supports our claim. The definition literally is scientific data that is appropriate and sufficient to support the claim. So in this example, I want you to circle the evidence that helps the claim that we have made. 3 things here. Mr. Hall has a guitar, Mr. Hall plays guitar every weekend, and Mr. Hall's family likes to play music. Now, you circle that which is relevant into our case here. And then finally, the reasoning. Reasoning is a justification that shows why the data counts as evidence to support the claim, and it includes appropriate scientific principles. Reasoning links the evidence and data to the claim. Now, going back to our example, Mr. Hall must be good at guitar because he plays guitar every weekend. Since practice helps someone get better, playing every weekend must make him good. Also, Mr. Hall comes from a family who likes music, and that must mean he's good. As we continue, consider what information you know about Mr. Hall and his guitar. Was the evidence used appropriate
and sufficient to make the claim? Now, what I want you to do is consider all of the things that you know and make a list of the appropriate evidence, and then evidence that may not have been useful, and then make a list of the evidence that would have been helpful to determine whether Mr. Hall is good at guitar or not. In other words, you need to ask yourself, did the evidence used directly support the claim? Is there other evidence that would be more appropriate? Thirdly, was there enough evidence to make the claim? And then finally, when is there enough evidence to support that claim? So now go back and look at your data that you've accumulated, and let's make a stand one way or another. Should Mr. Hall be considered good at the guitar, or not good at the guitar, or is there just not enough evidence to state one way or the other?